Hello, friends and fellows. We are Team AlphaBot, and we're from Taiwan. So obviously, as you can see in the picture, our product is the little black guy with a camera on his face. His name is AlphaBot. So why do we want to design a humanoid robot? For the past 2 decades, different kinds of robots have thrived around the globe. And among all of those robots, bionic humanoid robots are the dream of the human generation. People have been putting enormous amount of efforts into design of humanoid robots, such as rescuing robots or service robots. So let me put it this way. Imagine all of you guys are in a mall shopping. While this time, there's a bomb, a timing bomb, right beside you setting up by a terrorist. Tick tock, tick tock. What if now there is a humanoid robot which can move rapidly toward the bomb, recognize the bomb, and even dismantle the bomb for you? Wouldn't that be a marvelous thing that could happen in your life? So, for a solution to this kind of scenario, Team AlphaBot introduced our design, AlphaBot. So what is so special about our AlphaBot? AlphaBot is a 1/12 life-size 17 domain of freedom robot, which looks very much like human being. It has the ability to transform from human to car mode, which enables it to move from spots to spots very rapidly. Also, we enabled this AlphaBot to walk on its legs, so it enabled it to be able to travel in different circumstances, such as mountain climbing or rock walking, things sort of like that. Also, in order to enable it to recognize, to accomplish more complicated tasks, we equipped him with the ability to recognize image patterns via deep learning technologies. Last but not least, we allow users to task model these robots via an Android app to allow users to make slightly adjustments to the robot's movement while they can stay at a safe environment. So after knowing all those functionalities of the AlphaBot, you might wonder, why do we want to build our robot from FPGA? So while we're designing this robot, there are some thoughts we have. FPGA-based robots outperform CPU and GPU robots in the following ways. First, while we are developing transforming abilities, we found out that during transformation actually requires highly coordination between servo motors, which means that FPGA-based robots transform smoother than CPU-based robots. Next, while we're designing deep learning algorithm, while we're designing our convolutional neural network, we compared our FPGA with an NVIDIA GTX 660 GPU and an Intel i5 CPU. And surprisingly, we found out that by sacrificing slightly of the timing, we can get a much lower time and cost constant. So let us quickly overview AlphaBot system block diagram. The user sends commands through an Android app to control the robot. The Android app processes those commands via Bluetooth and sends to the Arduino gateway. The Arduino gateway processes the commands and transforms it into I2C commands and communicate with DE2115 board and our robot architecture. The task decoder inside DE2115 decodes those I2C commands and transform them into some button control signals to our two main hardware architecture, which is the feed-forward CNN and robot control system. And by the way, all of our architecture except the UI and the Arduino gateway, we implemented through Verilog. We did not use all of the NEOS processor because we wish the servo could move more smoothly, and we wish the performance could be better. So in order to make our robot to walk on its legs, we did a lot of math calculation, the inverse calculation for biped walking. So as you can see in the following diagram, we actually calculated the inverse kinematics of the vertical balancing and the horizontal balancing of the biped robot. This is our convolutional neural network. As you can see, we feed in a handwritten digit and its data sets into our convolutional neural network. by the way, is 100 by 100. And the data processed through one convolution layer, one max Boolean layer, and one fully connected layer, and finally ends up in the output layer, and outputs the data distribution of the answer label. We can get a 95% accuracy on MNIST data sets. So the next problem would be, how do we port this software design onto our hardware architecture? So for this, we took reference from Microsoft's Catapult project, and we come up with our own design of CNN on FPGA. So as you can see, the processing elements can actually process those data in a very fast speed, while it can use two hardware skills, such as data pipelining and parallel computing. So as you can see in the picture, we've utilized 58% of the logic elements, 80% of the memory elements, and 12% of the DSP units, which means that we did not reach the limit of this board. Once we have more memory elements, we can definitely scale up our design to make it to be a more complicated model. The result of our convolutional neural network is as follows. We can recognize an image in 16.88 milliseconds per frame. This model can adapt to anyone's handwritten digits. And this model and this hardware architecture is scalable to different recognition tasks. Finally, let me recap what I just said. So AlphaBot is a humanoid. It can transform, it has high mobility, it can walk, it can be task modeled, it can be wirelessly controlled, it can recognize image, it has a user-friendly interface, it is scalable to different tasks, it is designed from scratch, and last but not least, it is based on FPGA. Combining the three most popular skills in this era, which is robotics, deep learning, deep learning, and FPGA, we are confident that FPGA-based robot will thrive in the near future. Next, let's start the video.
Supposed to
Unfortunately, we couldn't cover all the details in this 10 minutes, but we're happy to have all you guys right there in our booth at the corner. And we're happy to share further technical details if anyone's interested. Thank you.